Alright, make y'all this quick video showing y'all how to do this stuff. So right here, man, look, listen, use the limit definition to find the derivative. Alright, so here's the limit right here. The limit as delta x goes to 0. We got to do f of x plus delta x minus f of x all over delta x. So what that means is, guys, alright, please pay attention to this. And if not, rewind it, look again, okay? We have a limit here. All right. Well, first of all, let me start by doing this. Let me find a prime for you. All right. So we know that's 2x. All right. The derivative is 2x. So when I solve this, my answer should be 2x. Okay. What we got to do with limit, all right, is we've got to do f of delta x or f of x plus delta x. So everywhere there's an x, I'm going to put this. So I do x plus delta x, and then I'm going to square it because it's squared right there, minus 4. All right, so that's this part, f of this. I evaluate it for this, and then I'm going to do minus the original f of x, like that. I'm going to put all that over delta x. All right, if you missed that, do it again. But basically, you got to take the original, you got to take the equation and plug this in place of x, like that, okay? And it's still, because it's minus 4, and then you got to subtract the actual function. So there's the function. Now, when you square this, because it's squared, all right, here I'm going to do it, well, here, x times x is x squared. Then x times delta x is x delta x, and then you got to do that twice. So that's 2 delta x. 2x delta x. All right, just write that out twice like this. And for that, and you'll get this right here. And then delta x times delta x is delta x squared. All right. Then remember, I still have the minus 4 right here. Let me move this over. And then I have minus, distribute this negative here. So minus x squared plus 4. And all that is over delta x. Now, let's look at it real quick and see if we can cancel anything out. All right, x squared cancels with that negative x squared, and that negative 4 cancels with that positive 4. So I'm left with 2x delta x plus delta x squared all over delta x. All right, and don't forget we're doing the limit, right? As delta x goes to 0. I wonder why I did that. Now, right here, factor out delta x. So we got the limit as delta x goes to 0. I factor out a delta x. That gives me 2x plus delta x all over delta x. All right, see, delta x times 2x is 2x delta x, and delta x times delta x is delta x squared. So that cancels. So now I have the limit as delta x goes to 0 of 2x plus delta x. Well, the delta x is 0, so I plug in 0 or plus 0, right? I get 2x. So this limit right here is the same as the derivative we got. So that works. All right, because I got the same answer, that's 2x, as I did onto the derivative. So the derivative using the limit is the same as the actual derivative. All right. So you do this one the same exact way. All right. 42, wait, does 42 have the same directions? Yes, same thing. All right, same as that thing. I know this is out here. Don't get confused by that. All right, same as that thing. All right, for this one, keeping it the same exact way. Let me use another color. We're gonna plug in 2x plus delta x squared minus 1 right? You got to plug in delta x right first into the equation minus the original equation all over delta x. All right, and we're looking for the limit of that. So real quick before I start, let me tell you the derivative. If you look at that, the derivative is going to be 4x, right? So let's see if we get 4x. First, we need to do that twice. So we're going to go 2 times. Remember, for that out, it's the exact same thing we did a second ago. So x squared plus 2x delta x plus delta x squared minus 1. And then distribute this. So that's plus. No, I'm sorry, that's minus. Alright, so that should be, alright, minus 1 minus 2x squared plus 1. Hello, all over delta x. Alright, so now distribute this 2 real quick. So we got the limit. Let's go to x. Goes to 0, sorry. 2x squared plus 4x delta x plus 2 delta x squared all over delta x. Oh, my fault. Minus 2x squared plus 1. Anyway, now let's see what it cancels out. So we have 2x squared cancels with 2x squared. Man. And 1 cancels with, oh, I forgot to write the negative 1 right here. Minus 1. So those 1s cancel out. See the 1s there cancel. Alright. So I'm left with the limit as delta x goes to 0 of 4x delta x plus 2x 2 delta x squared, like that. And now I'm going to factor out a delta x. And that is 4x plus 2 delta x, right? Because delta x times delta x is delta x squared. So I'm left with the limit as delta x goes to 0 of 4x plus 2 delta x. And delta x is 0. So if I put it in 0 right here, right? That's 0, guys, 0. And 4x plus 0, 2 times 0 is 0. So 4x plus 0 is 4x, which is what we got onto the derivative. So that checks out, okay? All right. Over here, let me clear this page off real quick. I got a lot of writing on it. Oh, delete the whole page. Clear ink from the page. There we go. That's what I want. All right, this problem right here, find the value of the derivative at the given points. All right, for this point right, or this question right here, find the value, all right, or the mean of the derivative at the given point. All right, so we just need to take the derivative, all right, of this right here. So first, I'm going to, well, hey, no, I'm going to use the chain rule right here. All right, so the derivative of the outside times the derivative of the inside. All right, so the derivative of the outside, all right, if you did u substitution, you'd have u squared, and then u would be 2x plus 1, like that. And then L prime would be 2u, and then u prime would be 2. And then you remember you put u back, so 2 2x plus 1, and then times the derivative times 2 equals 4 2x plus 1, like that. So that's the derivative right here. This is y prime. Alright, so now that I have y prime, I'm going to do y prime of 0. So I have 4 times 2 times 0 plus 1. So that's 0 plus 1 is 1. 1 times 4 is 4. So the slope right here, I put mean up here earlier. I'm sorry, slope. Slope is 4. Now this one, it says find the equation of the tangent line. Alright, this one we got to find the actual equation. So we do the same thing. We take the derivative, 3x squared plus 1. Then we need to find the slope. So we're going to plug in the x value. So 3 times negative 1 squared plus 1 gives us positive 1. 1 times 3 is 3. 3 plus 1 is 4. So this is the slope, m. So then we use y minus y1 equals m times x minus x1. So y minus y1, well, y1 is negative 2, so y plus 2 equals m times x minus x1, so that's negative, so that's plus 1. All right, so you can leave it like that, or you can simplify it as y equals 4x plus 4, 4 minus 2, so 4x, 4 minus 2 is 2, oops, plus 2. So that or is the equation of the line, okay? All right. Let's see here. All right, this question right here. Find the average velocity. So first we gotta find the average velocity, part A. So to do part A, what you gotta do is you gotta find, for this interval here, you gotta find S of 2 first. So that's negative 16 times 2 squared plus 555. And that gives me 491. So I have the point, that's a semicolon, guys, 2, 491. All right. Then I got to find S of 3. All right. S of 3 is going to be negative 16 times 3 squared plus 555. All right. And that's going to give me 411. All right. So that's a semicolon. This point is 3, 411. So now I use m equals y2 minus y1 all over 3 minus 2, and that gives me negative 80 over 1, which is negative 80 feet per second. All right, so negative 80 feet per second is the average velocity right here. Then part 2 says find the instantaneous when t equals 2. So for the, and t is 3. So for the instantaneous, all right, I got to take the derivative of this. So S prime equals, that's going to be negative 32t, like that. So now that we have a derivative, we got to find, oh, that became too big again. We got to find S prime of 2. So negative 32 times 2 equals negative 64. And S prime of 3, which is negative 32 times 3, which is negative 96. All right. So the average velocity of negative 80 is between these two. All right, which corresponds to the average. All right. So we're good. All right. Take the derivative since instantaneous. All right, cool. So we got the instantaneous. All right. Now, part C, Find the instantaneous right there. Part C says, how long will it take for the silver dollar to hit the ground? Man, sorry, man, these Reese cups. Well, think about it. Part C, H has to be 0. The height has to be 0. All right. So if I take here, I'm gonna bring C right here. If I take 0 equals negative 16. Oops, 16. Right, and then I solve. All right, I solve for T. So subtract 555. Right? And then divide by negative 16 on both sides. That'll give me well, if you divide by it, it'll just be negative 16. Oh, sorry. Negative 555 divided by negative 16. It'll just be that. And then I take the square root on both sides. So T equals, if you do that, you get 5.9. So T equals 5.9 seconds. So it's going to take 5.9 seconds for this thing to get to the ground. All right. And then lastly, for part D says find the velocity when it hits the ground. All right. So we just use the instantaneous deal, man. So if we have S prime of 5.9 equals negative 32 times 5.9. And that gives us negative 188.8 feet per second. So that's how fast the coin is falling. Right there. All right. Keep it going. So for this one, you want to find your critical points first, because it says find critical values. So we take the derivative. All right. Take the derivative first to find your critical values. All right. So 3x squared minus 12x. All right. Now we should that equals 0 and factor it. Take out 3x. Right? So we have 3x equals 0. X minus 4 equals 0. And we solve those, we get x equals 0 and x equals 4. So those are my critical values. So we're going to use our critical values down here, 0 and 4. Now remember, we're going to test everything, all right? So I'm going to use another color right. Negative 1, I'll do 2, and 5. I'm not going to do 2. 2 is too hard. I'm going to do 1. Easiest numbers to work with, 0 and 1. All right, these are my test values. So I do the original. No, I do the derivative. So I'm going to do y prime of negative 1. So that's, I plug it into this. 3 times negative 1 squared minus 12 times negative 1. So that's 1, that's 4, that's positive 12. 4 plus 12 is positive. All right, it's positive 16, which is positive. So this is positive. Right? Then I do y prime of 1, which is 3 times 1 squared minus 12 times 1. So 1 times 3 is 3. 3 minus 12. Oh, you know what? I messed up right here. Because that's 1, that's 4. I mean, that's 3. That's 3. 3 times positive 4 is 15. But that's still positive. All right, right here. 3 minus 12 is going to be -9. So that's negative right here. And then y prime of 5 is 3 times 5 squared minus 12 times 5. So 25, 75 minus 60 is going to be 15, which is still positive. So that's positive, right? So positive, negative, positive. Think about it. Positive, it goes up, then it goes down. So that means on this point, we have a maximum. And then from here, negative, it goes up. And then right here, we have a minimum. All right. So if you graph it, you can use your graph. You'll see it at 0, whatever. All right. 0, 0 is positive if you graph it. And then you go down here, it was like 432. All right. Is the minimum. So max is 0, 0. And min for -32. All right. All right. The other way to check those is just to plug them into the original. If you plug 0 right here, 0 minus 0 is 0, because 6 times 0 is 0. If you're plugging 4, right, for 64 minus 16, -6, that's -32. All right, 64 minus 96. -32. All right, good stuff. Right here, find the absolute extrema. All right, find the absolute extrema on the functions on the closed graph utility device. All right. All right. How I want to do this is the exact same way. All right. Now back to this one. Let's see here. So this one basically gave us our critical point. All right. So doing this is, I think, a little bit easier. All right. And here's why. What you do on this problem is we're first going to find our derivative again. So f prime of x would be 3x squared minus 6x. All right, like that. And then what we're going to do is set it equal to 0 and solve it. So factor out 3x. You have, all right, so factor out 3x, and that leaves us with x minus 2. 3x squared negative. Okay, cool. So we set each one of those equal to 0. This one gives us 0, and this one gives us 2. All right, so again, those are our critical values. All right, so we got to test some values. So -1, 1, and 3. All right, so we do f prime of -1. So that's going to be 3 times -1 minus 6 times -1. Oh, squared, sorry. So that's 1, 3. 3 plus 6 is 9. So that's positive. And then f prime of 1 times 1. So 1, 3, 3 minus 6 is -3. That's negative. And then 3. Uh, 9, 27, -18. -9, so that's negative, right? No. That is still positive 9. Sorry about that. Positive 9. Right? So the graph, if you graph it, you know what I'm saying, it'll look kind of like the other one. did. But anyway, though, man, what you got to do now, because we have these endpoints right here, is we got to check f of 0 in the original. So 0 cubed minus 3 times 0 squared equals all 0. All right, so the max, well, hold on. Yeah, we got a max at 0, 0. We plug in 0, we got 0. And then we do f of 2, right? So we have 2 cubed minus 3 times 2 squared. So that's 8, 4, negative 12. 8 minus 12 is going to be a negative 4. So we have a minimum at 2, negative 4, right? And then we need to check the endpoints. All right, the endpoints are right here. Okay, so we check f of negative 1. All right, f of negative 1 would be negative 1 cubed minus 3 times negative 1 squared, which will give me negative 1 positive negative 3. So that's negative 4. All right, which is the point negative 1, 4, negative 4. And we got to do f of 3. All right, which is 3 cubed minus 3 times 3. So that's going to be 3. That's 0, right? 9 minus 9 is 0. So we have the point 3, 0. All right. And so we have a relative minimum. All right. Where's the lowest minimum? Negative 1, negative 4, 2, and 4. Here's the relative minimum. All right. We saw that on the graph if you graph it. And then we have a relative max right here. All right. So these are the relative max and min. All right. And then it says the endpoints of the intervals are not extrema since they have the same value as the critical points. So see how these have the same values, right? Negative 4, 0, 0. All right. They have the same points as the critical points. So they're not extremas. Okay, they're not extremas. All right. Last problem of the day, exponential model. All right. Man, I need paper for this. All right, so dang, I need that on the same page so I can refer to it. It's all good. So here we go right here. It says complete the table for each radioactive isotope. All right. So yeah, that's what we're gonna do. So look, initial quantity. Well, look, y'all don't know the half-life equation, but Y equals CEKT. Or you need that equation where the initial quantity is C. All right, this right here, amount after 10 years. All right, the amount after 10 years, or after 1,000 years. Holy crap, man. This right here is going to be one of the Y values. All right, and, or after, hold on, I'm sorry. This is a Y value. All right, this right here, half-life in years. All right, half-life in years. This is time. All right, and then this is going to be a time, and this is going to be a time interval. So let me explain how we use those. So for 15, all right, let's find K first. All right, the constant value. All right, and to find that constant value, what we need to do is for 15, how we started is find K first. All right, because K equals constant of probability. No, constant of proportionality. Sorry, guys. Proportionality. All right, cool. Constant of proportionality. All right, so how we do that is we use that equation. Well, think about it, right? We want half-life. All right, so we want half of C. All right, so we're going to let Y equal 1/2 C. All right, because we want half of that. So when we set up our equation, we go 1/2 equals C E K to the T. Well, we know the first time is 24,100. All right. And now we do just like we did today in class, where we solve this thing for C. All right. Oh, this is 1/2 C. Sorry. I just said it. So now we divide by C first on both sides. So C's cancel. So I have 1/2 e to the k of 24,100. And now we're going to do ln on both sides. And the reason we do that is so we can cancel out that e. So we have k times 24,100 equals ln of 1/2. And now we just divide on both sides by 24,100. All right, so when you do that, you get k equals negative 0.0000288. I know when you're doing your calculator, it says negative 0.288 and some numbers e to the negative 5. Well, if you move that decimal, 1, 2, 3, 4, 5, that's what you'll have right there, okay? So I know what k is now. That's my constant proportionality. All right, so now I'm going to use k to find the kilograms at 1,000 years. All right, so I need to find it. Does it say kilograms? Well, after 1,000 years, all right. Let's figure it out, the grams after 1,000 years. So we go back to our original equation, all right. We got to find C, all right, the initial. So we have, for this year right here, 15, we know it's 2.1 after 1,000 years. So we're going to find the initial. So 2.1 equals the initial, we don't know. All right, times e raised to the k. Times, nope, 1,000 years. It told us 1,000, so we don't need that. We need 1,000 years. Sorry about that. Like that. All right. So now we just solve it. And how I'm going to solve this is I'm going to go ahead and divide by e raised to the negative point. Well, here, I'm going to multiply that. Well, yeah. When you multiply that, let me backtrack. All right, there we go, right there. Now, you can see 1,000, 3 zeros, so 1, 2, 3, right there. So 0.028. Now I'm going to divide both sides by e to the negative 0.280, excuse me, 0.0288. Oh my gosh. Like that. All right, on both sides. So that cancels. So I get C equals 2.1 divided by e to the negative 0.0288. And when I do that, that is going to give me 2.16 grams. All right. So this is 2.16. And then we just got to find the amount after 10,000 years. All right, so we go back to our equation. All right, y equals 2.16, because that's our initial. E to the negative 0.0, our k, our constant k, 288 times 10,000. All right, which gives us 4 zeros, 1, 2, 3, 4, 2, point, negative 0.288. Right, and when you do that, you get 1.62 grams after 10,000 years. All right. All right, I'm gonna actually start right there, man. This one, exact same type of problem, man. I hope this helps, and I will see you doing your performance run. Catch you later.